ready for liftoff. In this deep dive, we're exploring the cosmos, guided by Carl Sagan and his masterpiece, Cosmos.
Yeah, Cosmos is more than just like a tour of the universe.
Yeah.
It's about, uh, well, it's about us humans in our quest to figure out where we fit in this whole grand scheme of things.
It really is mind-blowing to think how far we've come in terms of our understanding.
Oh, absolutely.
And Sagan starts by taking us way back, to the beginning, to the time of ancient myths,
Oh, yeah.
like the Popol Vuh. That's a Mayan creation story,
Yeah.
where these sorcerers, they knew almost everything about the world.
It's fascinating, isn't it, how, like, all these ancient myths, they really show how deeply humans have always wanted to understand the world around us.
Right.
And the Popol Vuh sorcerers, with all their knowledge about the heavens and the earth,
Yeah.
I mean, they really embody that, like, yearning, for cosmic understanding.
But then the creator in the story, he gets nervous about how much they know
Oh, yeah.
and limits their vision. It's as if knowledge itself was seen as like a threat.
And that fear of knowledge, I mean, that's something we see pop up again and again throughout history.
Oh, for sure.
Whenever new ideas come along and challenge the old ways of thinking.
It's like people are afraid of what they don't understand.
Yeah, exactly.
And Sagan also brings up other creation myths like the Eskimo raven
Oh, yeah.
and the Chinese Panku, this being who shaped the world with a hammer and chisel.
That's right.
It's amazing how these stories from all these different cultures, they grapple with that same question of where everything came from.
They use these powerful images and metaphors, that resonate with us.
Yeah.
Whether it's a raven or a cosmic egg or a giant shaping the world, they represent our earliest attempts to make sense of the universe and its origins.
Hi, it's like trying to find meaning in the vastness of it all. And then Sagan shifts gears and he takes us from those ancient myths to this mind-blowing concept,
Yeah,
the Big Bang.
right.
What a huge change in perspective.
It really is. I mean, the Big Bang Theory with this idea of the universe emerging from a single point of unimaginable density.
Yeah.
It's like this monumental leap from those mythical explanations to a scientific understanding of how it all began.
And from that incredible beginning, the universe expands and then galaxies start to form.
Right.
These giant swirling clouds of stars held together by gravity, like our own galaxy, the Milky Way.
Exactly. And it's the interplay of gravity and angular momentum that shapes these vast structures. It's a delicate dance of cosmic forces.
Mhm.
And our Milky Way, it's actually part of the local group of galaxies.
So it's like our cosmic neighborhoods.
That's a good way to put it, yeah.
And it's crazy to think that even our galaxy, as huge as it is just one of billions in the observable universe.
Yeah, just imagine that for a second.
And within those galaxies, stars are constantly being born, living out their lives, and then dying in these spectacular explosions.
Supernovae.
Right, supernovae.
Right.
And those supernovae aren't just endings, right?
No, not at all. They're also beginnings. Because the elements that were forged in a star's core get scattered into space during these explosions. And then they become the building blocks for new stars, planets, and even life itself.
Oh, wow.
Think about it. The iron in your blood, the calcium in your bones, all of that was forged in the hearts of stars billions of years ago.
So we are literally made of stardust.
We are.
We are connected to this grand cosmic story.
Absolutely. It highlights this interconnectedness of everything in the universe. We're all part of this grand cosmic cycle of creation and destruction.
It's mind-blowing. So we've gone from these ancient myths to the Big Bang to galaxies to the life cycle of stars. Where does our cosmic exploration take us next?
Now we're going to shift gears a bit. We're going to dive into the history of scientific thought itself. We're going back to ancient Greece, to these philosophers called the Ionians. They were among the first to look for natural explanations for the universe.
So we're talking about thinkers like Socrates, Plato, and Aristotle.
Actually, we're going back even further to philosophers like Thales and Anaximander and Democritus. These thinkers, they predate Socrates, and they really laid the groundwork for what we now call the scientific method. They were pioneers in observing the world around them and trying to come up with explanations based on natural phenomena, not supernatural forces.
Okay, so who were these guys, and what kind of ideas were they exploring?
Well, Thales of Miletus, he lived around 600 BC. He's often considered the father of philosophy. He was really fascinated by the natural world and questioned all those traditional explanations that relied on the whims of the gods. For instance, he wondered if water was the fundamental substance from which everything else was derived.
Water. That's an interesting choice. Why water?
Well, think about it. Back then, water was essential for life. It could exist in all these different states, solid, liquid, gas. and it could transform and shape the landscape. So to Thales, it might have seemed like a plausible candidate for the primal substance of the universe.
I see his point. What about Anaximander? What were his contributions?
Anaximander, he was also from Miletus and a student of Thales. He took things a step further and proposed this concept of epeironon. It was this undefined, boundless primordial substance, and he envisioned a universe governed by natural laws, not divine intervention. This was a truly radical idea for his time.
So they were moving away from this God-centric view of the universe
Yes,
towards a more rational scientific perspective.
exactly. And then there's Democritus, often called the laughing philosopher.
The laughing philosopher, why was he called that?
Well, there are different interpretations, but it's thought that he had this really joyful disposition, found humor in the human condition, even while contemplating these deep mysteries of the universe. Didn't take himself too seriously. But don't let that fool you. Democritus made some really significant contributions to science.
Like what?
Well, he's the one who came up with the atomic theory, the idea that all matter is made up of these tiny, indivisible particles called atoms. This idea wasn't widely accepted until much later.
Right.
But it was remarkably prescient. And he even imagined the possibility of other worlds existing out there in the universe.
Wow, atoms and other worlds. That's incredibly forward-thinking for someone living in the 5th century BC.
I know, right?
It makes you wonder what other groundbreaking ideas might have been lost or dismissed throughout history.
You're absolutely right. And speaking of lost knowledge, that brings us to the tragic story of the Library of Alexandria.
Oh, yeah.
This library was one of the greatest centers of learning in the ancient world. It housed this vast collection of scrolls and texts from all these different civilizations.
And then, tragically, it was destroyed by a series of fires. Just imagine all that incredible knowledge that went up in flames. It's a reminder of how fragile our accumulated knowledge can be.
It is. It's a poignant reminder of how easily knowledge can be lost and how important it is to preserve and share our discoveries. The destruction of the Library of Alexandria was a huge setback for humanity's pursuit of knowledge.
But despite setbacks like that, the human quest for understanding continued.
It always does.
And that brings us to another important figure in the development of our cosmic perspective. Who's next in this journey of discovery?
Well,
You know, it's amazing how for centuries humans believed that the Earth was the center of everything.
I know, right? It seems so natural just based on, what we see every day.
Yeah.
That geocentric view with the Earth at the center, it was the prevailing belief for a very long time. But even back then, there were some people who dared to question that.
Like who? Who are some of those early challengers to the Earth-centered view?
Well, one of the earliest was Aristarchus of Samos. He lived in the 3rd century BC. And get this, he proposed that the Earth and the other planets, they actually revolved around the sun.
Wow. So the idea of a sun-centered solar system was already being discussed way back then. Why did it take so long for that idea to catch on?
Well, Aristarchus's ideas, they faced a lot of resistance. His writings on the subject were lost for centuries. And the prevailing view, supported by people like Aristotle and Ptolemy, was that the Earth was stationary at the center of the cosmos.
It's incredible how long those old ideas persisted. What were some of the main arguments against a sun-centered system?
One of the biggest challenges for early astronomers was explaining why we don't feel the Earth moving if it's actually orbiting the sun.
Yeah, that's a good point.
They also couldn't detect something called stellar parallax, which is this slight shift in the apparent position of stars as the Earth moves in its orbit.
So it was this lack of evidence and like a difficulty in, reconciling the idea with everyday experience. It took new observations and a fresh perspective to really shift the paradigm. Who were some of the key players in that scientific revolution?
Well, in the 16th century, we have Nicholas Copernicus, who actually revived Aristarchus's heliocentric model. He carefully analyzed astronomical data and presented a very compelling case for a sun-centered solar system.
So it sounds like Copernicus was willing to challenge those established views of his time.
He was. And his work, although controversial, laid the foundation for a complete transformation in our understanding of the cosmos. But it's important to remember that scientific progress is rarely the result of one person's work alone. Copernicus built upon the ideas of those who came before him, and his work inspired others to make further discoveries.
It's like a chain reaction of knowledge.
Exactly.
Each discovery leads to another. So who else played a significant role in solidifying this new model of the solar system?
Well, Johannes Kepler comes to mind, a brilliant German astronomer. He was fascinated by this idea of an underlying harmony in the universe. Kepler spent years meticulously analyzing the observational data collected by his mentor, Tycho Brahe. And I'm talking about incredibly precise data.
So what did Kepler find in all that data that helped to explain the movements of the planets?
Well, his analysis led him to a truly groundbreaking discovery. Planets don't move in perfect circles around the sun, as was previously believed.
Oh,
Yeah. Instead, they move in ellipses, with the sun at one of the two foci of the ellipse.
mm.
This was a radical departure from that ancient Greek idea of celestial perfection, but it fit the data perfectly.
So Kepler cracked the code of planetary orbits, but did he also understand why planets move that way?
That explanation would come a bit later with Isaac Newton and his law of universal gravitation.
Oh, gravity.
Newton showed that every object in the universe attracts every other object with a force that depends on their masses and the distance between them.
Gravity, the force that keeps our feet on the ground and governs the movements of planets and stars. It's amazing to think that the same force that makes an apple fall from a tree is responsible for keeping the planets in orbit.
It is mind-boggling, isn't it? Newton's law of universal gravitation was a monumental achievement. He was able to mathematically describe this force and explain why planets follow those elliptical paths around the sun. His work unified our understanding of celestial and terrestrial motion.
So we went from an Earth-centered view to a sun-centered solar system, with planets orbiting in ellipses because of gravity. But even our solar system is just a tiny speck within the Milky Way galaxy. What about our place within this immense galactic structure?
Well, that's where Edwin Hubble comes in. In the 1920s, Hubble, using powerful telescopes, made a discovery that changed our view of the universe forever.
What did he discover? Did he finally find those aliens everyone was looking for?
Not aliens, but something just as astonishing. He observed that distant galaxies were moving away from us, and the farther away they were, the faster they were receding.
Wait a minute, so everything in the universe is moving away from us. Does that mean we're at the center of some colossal cosmic explosion?
That's a natural thought. But that's not quite what's happening. The expansion of the universe isn't like an explosion from a single point. It's more like the stretching of the fabric of space itself. Imagine dots on the surface of an inflating balloon. As the balloon expands, every dot moves away from every other dot, but there's no single center of expansion on the balloon's surface.
So there's no central point in the universe that everything is moving away from.
Exactly. That's one of the most mind-bending concepts in cosmology. There's no center to the universe as we understand it.
Yeah.
Every point is equally valid as the center, so to speak.
Wow, that's definitely a challenging concept to wrap my head around. So we're not at the center of the solar system, and we're not even at the center of the galaxy. And there's no center of the universe at all. It kind of makes you feel pretty insignificant, doesn't it?
From a purely cosmic perspective, yes, we are quite small. But that doesn't diminish our significance as a species capable of comprehending the vastness of the universe and asking these profound questions about our place in it.
That's a good point. We may be small, but our ability to ask these questions and seek answers, that's what makes us unique. Speaking of seeking answers, one of the biggest questions humans have always pondered is, are we alone in the universe? Sagan dives into this question, exploring the possibility of extraterrestrial life. Where does he begin?
He starts with our fascination with Mars, a planet that has captured human imagination for centuries.
Mars, our planetary neighbor. It does have some Earth-like features, red dust, polar ice caps. It's easy to imagine that there might be something living there.
You're right, and that fascination goes way back. In the late 19th century, astronomer Percival Lowell became convinced he saw canals on Mars, which he interpreted as evidence of intelligent life.
Wait, were there actually canals on Mars? I thought that was debunked a long time ago.
You're right. Lowell's observations turned out to be mistaken. The canals he saw were likely optical illusions or misinterpretations of natural features. However, his claims fueled public interest in the possibility of Martian life.
So no canals. But what about other signs of life? Didn't we send probes to Mars to search for evidence of microbial life or something like that?
We did. In the 1970s, NASA's Viking mission sent 2 spacecraft to Mars, and they were equipped with instruments designed to search for signs of life, even at the microbial level.
And what did they find? Were there any signs of those Martian microbes?
The results were intriguing, but ultimately inconclusive. Some of the experiments suggested the presence of microbial activity in the Martian soil, while others did not. To this day, scientists continue to debate whether the Viking findings were truly indicative of life or the result of non-biological chemical processes.
So the question of whether there was or is life on Mars remains a mystery.
It does. It's one of the most tantalizing questions in planetary science.
Hmm.
And future missions to Mars, including sample return missions, might finally provide us with a definitive answer. But the possibility of life beyond Earth extends far beyond Mars.
Absolutely. I mean, considering the vastness of the universe, it's hard to imagine that we're the only living beings out there. Is there any way to estimate how many other civilizations might exist?
Well, there is a way to approach that question, although it involves a lot of unknowns. It's called the Drake equation, named after astronomer Frank Drake, who proposed it in 1961. It's basically a formula that tries to estimate the number of civilizations in our galaxy with whom we might be able to communicate.
That sounds interesting. What factors does the Drake equation consider?
It takes into account things like the rate of star formation in our galaxy, the fraction of stars that have planets, the number of those planets that could potentially support life, the fraction of those planets where life actually emerges, the fraction of those life-bearing planets where intelligent life evolves, the fraction of those intelligent civilizations that develop technology capable of interstellar communication, and the average lifespan of such technological civilizations.
Wow, that's a lot of factors. And it seems like there's a lot of uncertainty involved in each one.
You're absolutely right. The Drake equation is more of a thought experiment than a precise calculation. Many of the factors are highly uncertain, particularly those related to the development and longevity of intelligent civilizations. It's really just a way to frame the question and explore the possibilities.
Even if we can't get an exact number, it's still fascinating to consider the potential for other intelligent beings out there, maybe even sending signals across the vastness of space. But it also makes you wonder, if there are other technological civilizations out there, would they be friendly or hostile?
That's the million-dollar question. And it's one that Sagan explores in Cosmos by looking at how different cultures here on Earth have interacted with each other throughout history. He points out that first contact between cultures hasn't always gone smoothly. There have been many instances of conflict exploitation and even the destruction of entire civilizations.
That's true. Human history is full of examples of both cooperation and conflict when different cultures clash. It makes you think about how a technologically advanced alien civilization might treat us if they ever found us.
It's a sobering thought. And it leads us to another important theme that Sagan explores in Cosmos: the human capacity for both incredible good and incredible evil.
It seems like we've developed all this amazing technology, but we haven't quite figured out how to use it responsibly. And that brings us to what might be the ultimate existential threat facing humanity: nuclear weapons.
You're right. Sagan was deeply concerned about the threat of nuclear war, and he dedicated a significant portion of Cosmos to exploring the dangers posed by these weapons of mass destruction. He painted a stark picture of the devastating consequences of nuclear war. Not just the immediate casualties, but also the long-term effects of radiation, environmental damage, and the potential collapse of civilization.
It's terrifying to even think about it. Did Sagan offer any hope for the future, or was it all doom and gloom?
He did offer hope. He argued that our capacity for reason, compassion, and cooperation gives us a chance to avoid self-destruction. He highlighted some positive trends in human history, like the abolition of slavery, the advancement of women's rights, and a growing global awareness of our interconnectedness.
So there is hope, but it's not a guarantee. What can we do to make sure humanity chooses the path of peace and cooperation over conflict and destruction?
That's the big question, isn't it? Sagan didn't offer any easy answers. Instead, he urged us to understand our own nature, both our capacity for darkness and our potential for light, to help us navigate the challenges ahead.
And that understanding can come from science, right?
Yeah.
From exploring the universe and our place within it.
Exactly. Sagan believed that science wasn't just about acquiring knowledge, but also about understanding who we are, where we came from, and what our responsibilities are as a species.
It's a powerful message. Science is a tool for self-discovery and a guide for building a better future.
It really is.
We've covered so much in this deep dive into Cosmos.
We have.
It's been an incredible journey. From ancient myths to the Big Bang, from the life cycle of stars to the possibility of extraterrestrial life and those existential threats facing humanity.
It's quite a lot to take in.
It really is. It leaves you feeling both incredibly small and incredibly connected to something much larger than yourself. What were some of the things that stood out to you from Sagan's work?
Well, one thing that really struck me was how much Sagan emphasized the interconnectedness of everything in the universe.
Yeah.
We're not just observers of the cosmos.
Yeah.
We're a part of it, literally made of stardust.
It's true.
Our existence is intertwined with these grand cosmic processes that have been unfolding for billions of years.
That idea of being stardust is so powerful. It's not just poetic, it's like a scientific reality
It is.
that speaks to our deep connection to the universe.
Exactly. And Sagan reminds us that it's our ability to understand this connection, to decipher the laws of nature and unravel the mysteries of the universe. That's what makes us special. As he puts it, we are a way for the cosmos to know itself.
That's a beautiful quote. The universe becoming self-aware through us, through our scientific curiosity and our quest for knowledge. It's inspiring. But science isn't just about understanding the universe out there. It's
No.
also about understanding ourselves,
Yes.
our place in the grand scheme of things, and our responsibilities as a species.
You're absolutely right. Sagan argued that our scientific knowledge should inform our ethical choices.
Hmm.
We have a responsibility to use this knowledge wisely, to protect our planet and ensure the survival of our species. We've been given this incredible gift of understanding, and it's up to us to use it for good.
That sense of responsibility is something that comes up again and again in Cosmos. And Sagan really digs into the roots of violence and aggression, exploring factors like social hierarchy and territoriality, and those primitive parts of our brains that we inherited from our ancestors.
Yeah.
It's like we're still struggling with these primal instincts, even as we've developed technology that could destroy us.
It's a dangerous imbalance.
Yeah.
Sagan suggests that understanding these deep-seated tendencies within us is essential if we want to overcome them and create a more peaceful and sustainable future. He doesn't offer any easy solutions, but he does point to some research that offers insights into the nature of violence and aggression.
What kind of research?
Well, he highlights the work of James W. Prescott, who found a strong correlation between child abuse and societal violence. Prescott's research indicates that nurturing and affectionate care in early childhood are really crucial for developing empathy, compassion, and nonviolent tendencies.
It makes sense. If we want to create a more peaceful world, we need to start by creating a more loving and nurturing environment for our children.
Exactly. It all comes back to understanding ourselves, our motivations, and the factors that shape our behavior both individually and as a society. Sagan also points to some encouraging trends in human history. Things like the abolition of slavery, the advancement of women's rights, and a growing global awareness of our interconnectedness.
So amidst all the cosmic wonder and existential threats, there's a glimmer of hope for humanity.
There is, but it's not a guarantee. It's a choice. We have the potential for both greatness and self-destruction. The path we choose is ultimately up to us.
That's both empowering and a little daunting. We have this incredible capacity to shape our own destiny, for better or worse. This deep dive into Cosmos has been quite a journey, filled with awe-inspiring insights and some sobering reflections.
It really has. Cosmos expands our awareness of the universe while challenging us to think critically about our own nature and our role in this grand cosmic scheme.
Yeah.
It's a journey that leaves you with more questions than answers. But I think that's a good thing.
I think so too. Sagan wouldn't want us to just passively accept everything he said. He'd want us to keep questioning, keep exploring, and seeking our own understanding of the universe and our place within it.
Absolutely. He wanted to spark our curiosity and inspire us to continue that journey of discovery.
So what's the one big question that you think listeners should take away from this deep dive into Cosmos?
Well, if we've learned anything from Cosmos, it's that we're a tiny part of this vast and ancient universe. We have this capacity for both great good and great harm. So the question becomes, what role will we choose to play in this cosmic drama unfolding around us? Will we be the agents of our own destruction, or will we rise to the challenge and become a force for good in the universe?
That's a powerful question, and one that each of us needs to think about. It's a challenge to really consider our place in the cosmos and to use our knowledge and our actions to create a future worthy of our species and our planet.
I agree.
Well, it's been an absolute pleasure exploring these ideas with you. Thanks for joining me on this deep dive.
The pleasure was all mine.
And until next time, keep looking up at the stars and never stop asking those big questions.